question that Jackson was asking about right here, guys. What do we have to do with these two equations to get an answer to figure out when we would be equal? Some equal to each other, guys. How many equations do we really have up there? Two. With how many unknowns in each one? Two. We got an answer of 6, didn't we? Guys, when I plug 6 in down here, what's 6 plus 9? 15. When I plug 6 up here, 6 times 1.5 is 9. 9 plus 6 is what? 15. When we get an answer like that, we can write it as an ordered pair, 6 comma 15. Guys, we've talked about systems of equations. In fact, we just did in the question that was asked here before we started the notes. Systems of equations are equations where you have more than one equation with more than one unknown. So in this example, how many equations did we write up here for that problem? 2. With how many unknowns? 2. Now, you've been exposed to that in the past. You've done systems of linear equations where you've had 2 equations with 2 unknowns in the past. But guys, we're going to kind of look at the same thing with solving systems of linear equations, but today our question is not so much about 2 equations, 2 unknowns. The question wants to know, how can you determine the number of solutions of a linear system? And when we talk about linear systems, we're so used to talking about stuff in 2-variable form. But it turns out, guys, that we're going to start looking at visualizing solutions of systems of linear equations in not 2 variables, but what? 3. Okay? There's going to be an x and a y, and we're going to wake up the variable that's always sleeping today. Z. That was a good one, wasn't it? Okay? Oh, I thought it was pretty good.
Nice job.
All right, so we're going to also solve linear systems that are going to have 3 equations really with 3 variables algebraically. And this is going to get kind of tedious today, but I think you guys are going to knock this out of the park. I think once you see one example, you're going to be, is that it? And I'm going to be like, yep. And then we'll look at some real life problems. Now, okay, guys, we're not going to get through all this today. We'll do our best to try and get through at least the first 2 pages. So, that said, let's get some vocab established. Linear equation in 3 variables. A linear equation in 3 variables, x, y, and z, is an equation of the form ax plus by plus cz is equal to what? And a, b, and c are not all what value? 0. Can some of them be 0? Yes, but just not what? Okay, so you might want to underline it. Not all of them can be 0. Some can, but not all. So an example of an equation would be like, I don't know, 3x plus 6y plus 2z equals 12. Okay? That would be an equation in 3-variable form. All right? So our job today then is to solve systems of 3 linear equations right here. So basically we're going to be working with how many equations here, kids? 3. 3 equations with 3 unknowns. And an example over here. How many equations do you see? And how many unknowns in each? X, y, and z. Right? Guys, like I wrote 6 comma 15 at the very top, that would represent an x comma y coordinate. So today our solution of a system of 3 linear equations is going to look like the following. It's going to be an ordered, not pair anymore, but an ordered triple. So when I write an answer, I might write an answer as like 3 comma 7 comma negative 4. This would indicate to me that the x value is what, kids? And y would be, and negative 4 would be the z value. So we just say a solution of a linear system is written as an ordered triple. That's the coordinate that makes how many of the equations true? All 3 at the same time. Okay, guys. So that ordered triple is that point x comma y comma z whose coordinates make each equation true. Now I will tell you guys today, there might be times where we run into an ordered triple, like we wrote up top, but there's also going to be times that when we do this, you're going to be like, hey, Parson. And I'm going to be like, hey, what? And then there's going to be like, there's no solution at times. Anybody want to guess what our other option might be? We got one ordered triple. Maybe there's no solutions, so no ordered triple, or maybe there are infinitely many solutions, okay? And you've talked about that idea when you've dealt with systems of linear equations of two variable form, okay? Guys, nothing's really going to be new today. It's just going to be more work. And again, I'm going to be honest with you. This is going to get a little tedious today. I'm going to do some things a little differently than most math teachers would do because I think it just makes sense the way I do it more than the way look, I'm going to be honest with you. How many of you forget to change signs sometimes when you got to switch stuff around? Okay? You want to know what the bad news about this is going to be today?
Signs a lot.
If you make one little mistake, everything is messed
Oh,
up.
that's trash.
Oh, I know, I hate that. You know how many mistakes I made in the second hour?
42.
It felt like 42, I'll tell you that much.
I don't know why that number came to my head.
I don't know. I'm just so glad I've got CRS and can't remember anything because I forgot about all the mistakes I made last time I taught this. All right. Hey, anybody need more time with the vocab part up here? Instead of two systems or two equations with two unknowns, we're going to talk about a system of equations with three equations and three unknowns. So let's take a look at this, kids. Oh, this is good stuff. I've got some rules up here for solving a three variable system. Anybody want to volunteer to read step 1 for me? Go ahead, Amy.
Rewrite the linear system in three variables as a linear system in two variables by using the substitution or elimination method.
So we're trying to start by going from three variables down to what, kids? 2, okay? So what step 1 is saying, and I'm going to write this kind of in a way that I think makes better sense. Get one variable to be the same. Get one variable to be exactly the same. So that's what I'm going to say for step 1. I'm going to kind of circle this to say, this is what this is really saying. Get one variable to be exactly the same. Okay? So we're going to look at example 1 together, kids. In my example 1, it says the following. It says solve a three variable system. In this case, I'm telling you there will be a what? Solution. Now you guys might want to have a calculator out to be punching these numbers in because I'm going to need your help. All right. Kids, I'm looking at the X's, I'm looking at the Y's, I'm looking at the Z's. The first thing you always ask yourself in a system like this with three variables and three unknowns, ask yourself, do any of those three variables have exactly the same coefficient in front of X, in front of Y, or in front of Z? Take a look at your X's. Are those coefficients exactly the same? 6, 10, and 12? No. How about the Y's? 8, 12, and 8. Are those the same?
No.
How about the Z's? 6, 14, and 20? No. Now if I had to ask you a question, based on variable X, variable Y, or variable Z, what would probably be the easiest one to get alike?
Why?
Why? It's okay if it's negative. I don't care about the negative right now. What were you saying, Gabe?
They're all factors of 4.
It could be all be multiples of 4. Yep, I like that.
Divisible by 4.
Okay. Gabe, can I ask you a question?
Sure.
Are you picking Y's because 2 of them are already 8s?
That too.
I like that. That's a good idea right there. Okay. Let me ask you a question. Is there any way that we can figure out what the least common multiple of the 8 and the 12 and the 8 are? In other words, what would be the smallest number that 8 and 12 would go into?
2.
Oh, think bigger.
No.
Think bigger.
24.
24 is the smallest number that 8 would divide into evenly, and 24 would also be divisible by what?
12.
12. Okay, so I'm thinking, are you guys okay if I work with the Y's first?
Yeah.
Now, I don't have to do that. I can work with the X's. With the X's, you'd have to turn everything to 60 because wouldn't all three of these values go into 60? I think the 8 and the 12 is easy. We know that goes into 24. All three of those go into 24, right? Okay, here's what we start by doing. All right? We're going to work with the Y's. I'm going to pick this column right here. All right? Guys, if I know that 8 and 12, 24 is the least common multiple, what would I have to multiply everything up here to make this 8y a 24y? I'll put a 3 out front here. We're going to multiply that by 3. Okay? What am I going to multiply everything in the second row by to make this some kind of a 24? 2. Now, some of you are like, hey, Parson, let's make it -2. Don't do that because here's what's going to end up happening. If you're going to start switching signs or forget a sign, don't do that. All right? What should I multiply this third row by then? Okay. All right, guys, right below this, I'm going to write this in. Let's do this. Oops. Help me with the top. 3 times everything up top. 3 times 6x would be what?
18.
And I would try and write kind of small, but be very organized with this too. 18x plus 24y minus what? 18z. What's 62 times 3? 186. So I took all parts up there times 3. Okay? I'll wait until I know everybody's got that first row written down. Guys, I need help on the second row. Multiply everything by what? 2. So do you guys agree 20x minus 24y minus 28z equals what, kids? 28. Right? Are we good on the second row, kids? Let's go to the third row. Everything times 3. What's that going to be? 36x minus 24y plus 60z. And I have no idea what 68 and 3 is. 180 and 24. Negative 204? Negative 204? Are we all in agreement with my numbers up here so far?
Yeah.
Now guys, by doing the multiplication to all 3 equations the way we did that, what stands out now? The second term, 24y's are all there. We're going to make those go away. We want to do what Amy said. Get 3 variables down to what first? 2. Okay? All right, here's how this is going to work. We're going to work row 1 and row 2. So I put a little arrow here, and I'm going to work row 2 and row 3. Okay? And this helps me a lot to do it this way. I'm going to pick some pretty colors today. How about that? You like that? Right. Yeah, football. Take a look at these first 2 rows right here. We want to make the 24y's go away. Now, kids, listen carefully. What kind of 24y do I have in the first equation?
Positive.
What kind do I have in the second one?
Negative.
Would I have to add these 2 together or subtract one from the other to make them go away?
Add them.
So the signs are opposite, right? I'm going to make a note up here. When we're making things go away, if your signs are opposite, you will do what? Add. So what I want to do down here with these drew these arrows, I want to say I want to add row 1 and row 2 together because the signs for the 24y's are opposite. Now, take a look at row 2 and row 3 we're going to put together. I'd like to make these take each other out. So when the signs are the same, how do I make them take each other out? Addition or subtraction? Okay, we would have to subtract here. So if your signs are the same for the variable you're trying to make go away, we would subtract. Okay, guys, help me with my north of Highway 3 math skills here. Here we go. We're going to take the first 2 rows and add them together. So let's add the x's together. 18x plus
20x
is, this becomes 38x. Okay, be careful. 24y plus negative 24y. What happens?
They cancel.
It's gone.
Bye-bye.
Okay? Be careful on this next one. Negative 18z plus another negative 28z.
Negative 46.
Minus 46z then, right? This will equal then 186 plus what? 28. And I believe that is 214. Okay, are you guys with me so far? Again, write small, write small, write small if you can. All right, so we're going to do the same thing with row 2 and row 3 now. But this time, instead of adding, we're doing what? Okay, help me out, kids. What's 20x minus 36x?
So we can use the middle equation for both directions.
Yes. I could unroll 3 and row 1 to get another one if I wanted to. I just think it's easier to do row 1, row 2, because they're right there with each other, and then do row 2 and row 3. You okay with that? Because I could have done 1 and 2, and then I could have done 1 and 3 if I wanted to. Okay with that? Okay. Help me out on the next one. What's negative 24y minus negative 24y? It's gone. When I subtract a negative, it's like adding, right? Keep that in mind. So this now becomes negative 28z minus what? Which would be? Okay, and then we've got to do 28 minus negative 204, don't we? Oh boy.
Negative 1.
When I subtract a negative, and this is where I get a little concerned. When I subtract a negative right here, doesn't this become addition? So this is really 28 plus 204, right? So 232?
Yeah.
All right. Cool! I've gone from 3 equations down to what?
2.
We were working with 3 variables. We've at least established it down to what there? That's step 1.
I read this a one. No. I don't know what you said.
This is gonna take a
I don't
I'm
know.
going to take a little while. Guys, if we said, let's go from 3 equations down to 2 with 2 unknowns, a perfect situation would be if I could get down to 1 equation with
One.
1 unknown. So we start working here, and this is where we do it. So what's step 2 say on the rules up there? Solve a new linear system for both variables. So that's what we do in this. Now guys, take a look at this. Did the x's match for the coefficients here? No. Did the z's match coefficient-wise? Okay, when that happens, I'm going to tell you, pick the coefficient that are easier to work with. In other words, the smaller. Okay, so should we work with x's coefficients or the y's coefficients? Okay, I'm going to go ahead and write down step 2 up here. I'm going to put a little something up here. I think you should do a little crisscross when you do this, all right? Crisscross will make you, oh my gosh, I'm old. You guys don't know that song, do you? Crisscross will make you jump, jump. Oh boy, I am old. And now I am sad because nobody knows what I'm talking about.
I think I know what you're talking about.
Okay, crisscross. Guys, up here, we'd like to get the x's the same. So I've got 38x up here and 16x down here. So we crisscross these coefficients. I'm going to multiply everything up here by 16. What am I going to multiply everything down here by now?
38.
Okay, now I'm going to make a little room here. So give me a second. Oh, how am I going to do this? I don't want this. Get that. Get rid of that. I could. I just choose not to because I know if I forget to change one sign, Jackson, if I forget to change one single sign, everything goes bad. And then multiply by a negative. You know what I mean? So what I'm getting at here, honestly, is that it's kind of got to be perfect with everything. And I don't like, I mean, I could, Jackson, and I like the way you're thinking, but by doing that, it creates an opportunity to make a mistake too. Hunter,
Where did we get the 16x?
where did we get the 16x
the bottom
from?
equation. You see that?
So I took
Yeah.
20x minus 36x. You okay with that?
Yeah.
Okay. Well, let's go, kids. I need your help. I need your mathematical help.
That's not the
We're going to take everything up top times what? 16. And this is where I totally screwed up in second hour. So don't let me do that. What's 16 times 38? 60. 608x. How about the 46 and 16? Sounds like the Viking Titan game this weekend. Titans 46, Vikings 16.
You guys really don't have any optimism.
Have you
But the
seen
Packers
them,
are still gonna
have you
win.
seen them play?
They're kinda terrible.
Oh, they're bad. 16 times 46. I don't know. Help me, guys.
Oh, bro.
736.
Oh no. Where's Odell at? Yeah.
214 times 16. Yeah, I was concerned last night. I was watching Miami and Jacksonville. I thought those two franchises are better than my team. Wasn't that good?
I thought it was going to be an awful game, but
What about Mitchell Trubisky?
Yeah, good God. That's not good.
Trubisky's overrated.
16 times 214.
34, 24.
3,000.
Yeah, draft it over.
3,424? Guys, check my math. Are we good on this? Okay, what are we going to multiply everything in the bottom by? 38. So this becomes negative 608x down here. Ooh, that's good. How about 38 times the negative 88 up there? It's a big number. Is it 3,344? 3344? And then I have no idea what 38 and 232 is. It's a big number.
8,816.
Just like that. Kids, take a look at your x's right now. Coefficients the same. Okay, let's get this down to one equation with one unknown, and then we'll pause it, go to lunch, and we'll come back and finish this one up. Okay? Am I going to add or subtract those, guys? Because the signs are the...
Opposite.
Okay, help me out, kids. These are going to go away. So negative 736z minus, or I'm sorry, plus negative 3,344z, negative 4,080z, right? Oh boy, I'm running out of room. So this is negative 4,080z. And I want this to equal, boy, is that 12,240? When I add these values on the end? Is that right?
Yeah, 2, yeah.
Yep.
Guys, what's that allow you to do right there?
Divide.
Divide, and all of a sudden we have a solution for what? Okay, so somebody divide that for me and tell me what z is equal to. What kind of 3? Okay, we've got one value there so far. Okay. Now, guys, is this going to take some time? Answer yes. All right. But like I said, we'll spend some time working at it. I'm going to pause right there. I think we go to lunch at 49.
Wait, so if we mess up one sign in this
I
whole
know,
thing's
okay,
trash.
well, don't. You know how many times I messed up in second hour?
17.
Oh, it was a lot. Where's the pause button at, guys?
Hello, I'm a copy.
So once we get this one right here, once we find a solution, we kind of crisscrossed right here. You know what I mean by crisscross now, once you get it down to 2 equations, like we did with 38 and 16. And we use that to get down to 1 equation. Now, guys, once we find an answer, it says substitute the values found in step 2 into the original equations and solve for the remaining variable. Well, guys, how many answers do we have? 1. So we would probably want to work up to an equation that has 2 variables in it. So you're going to come back up to here, and you're going to say, all right, I need to come back into here, and we need to plug z in. Now, do you guys want to work with this first equation or second equation? Okay, we're going to work with this first one right up here that says 38x minus 46z. So once I know this, I'm going to kind of make a little line down here for this. Kind of going across here. We know that z is what value now, guys? -3. So I'm going to come down here and start doing some work, okay? So now that I know that, I'm going to pick this equation right up here. We now know that 38 times x minus 46 times, what could I plug in for the z right here, kids? -3 now, right? And that's going to equal what value? 214, right? Okay, so help me with this, kids. I don't know the 46 and the -3. When I take a negative times a negative, this is going to turn into positive 138. And what's this equal on the right still? So by plugging z in, that's going to allow us to solve for what now? X. All right, well, help me. Subtract 138 from both sides. You've got 38x. Oh, Lordy, is that 76? Oh, boy. I like it when things work out nicely like this. What's 76 divided by 38?
2.
Hey, guess what, guys?
X is equal to
What do we need to find now?
Y.
So which of these, I'm gonna go back up into the original equation. I like to work with smaller numbers, so I'm just gonna pick this first equation to use. Is that okay?
Yeah, brother.
We'll be able to plug in for x, and we'll be able to plug in for what?
I was going to see.
So I'm gonna put a line right here for this next part. So I'm gonna have 6 times what, kids?
Two.
Plus 8y, right? Again, and here's the deal. I should back up and explain this better. Does it matter which of these 3 I pick? Because we're looking for the one ordered triple that's going to make all 3 of these true at the same time. Would you agree with that? So I'm going to have 6 times 2 up here for x, because x is 2. We don't know what y is, do we? Oh, do we know what z is to plug in here now? So minus 6 times what? And what do I want that to equal? All right, help me with my north of Highway 3 math skills. What's 6 times 2?
12.
Oh, is that plus 18? Is that right? You ahead of me already?
Yeah, well, we're not there.
So I've got 8y plus 30, don't I? Holy cow. What's y going to equal out of this mess?
Oh. Big problem.
And that, my friends, we're done. Almost.
Oh.
Because they're going to say, write this as an ordered what?
No.
Here.
Triple.
Triple.
Ordered triple. So like when you're going into big ideas, which
2, 4, 9, 2.
you got to make sure you put them in there. So how would I write this? What, comma, what, comma, what?
2, 4, -3.
2, 4, -3 is where those lines would intercept in a 3-dimensional coordinate plane, an XYZ plane. There's your ordered triple. So what point, or what XYZ ordered triple is going to make that system true?
That was a lot of work.
It is a lot of work. Okay, and the frustrating part is if you make a single mistake, I know. So perfection and paying attention to detail is going to be important. And I think I said this is going to be a bit of a challenge, right? Really was it's just a lot of number crunching, isn't it? Okay. And I think that it's going to be one of those deals where we think it's difficult because we've got a lot of work to do, okay? All right, what time will we get out here? 28? How about I make a deal with you? Let's get through example 2 here, and then we'll call it good for the day. Is that good? So just keep in mind, the only thing that you guys still have to do, if you've got anything from 2.3 or prior to that, get it to me. I'm not going to give you anything new. We'll pick this up on Monday, okay? All right, let's stop, guys. Which variable you want to get the same here?
Y.
Want to work with the y's again?
Yeah.
All right. I could work with the x's, I could work with the z's, it wouldn't matter at all. So we're going to get the y's the same, is that okay with everybody?
Yes.
So if I want the y's to be the same, what do I have to multiply this first equation by?
18.
I guess what kind of y value are you going to be? 18, right? I got to multiply this by 18. I've got to multiply this then by what?
I have a question.
Yes, sir.
For 1 and 2, could you multiply the top by 9 and the bottom by 0.5?
You could. There's a million different ways. I would have gone with the x's on this. I would have made this a 12, and a 12, and a 12.
I want the X's.
Let's go the X's.
I want
How many
I've already
started
wrote
y's?
down.
I want the X's.
I'm going.
It doesn't matter.
No, we'll do
You
X's.
should continue with Y because I already.
Let's go with y. Some of you guys already started writing it down. What do I have to multiply everything by here?
2.
What do I have to multiply? Ooh, I like this because you don't even have to change that one. Okay, here we go. So the top's going to be 18x plus what?
18.
Equals what? Now guys, I don't know if you noticed up there in example 2, it said solving a 3-variable system. What's going to happen here?
No solution,
Let
we
me
got the
show you.
answer.
You're gonna like this. You're gonna like this one better than what we did up here. Ones with solutions, you've gotta go all the way through this. There's gonna come a part in here where something just totally falls apart and it's like, we're done. Can't do anything more.
What's that?
Yeah, but that's when they
What's that?
Did you redo?
I think I did. Did I, guys?
Yeah.
I think I, yeah, I'm good. Thank you, Jackson.
What's that?
All right, what are you gonna have in the next one, kids?
12 18
What is-
y,
No,
4
it wasn't.
z, 20.
20?
Yay.
20 how much? I got that wrong, didn't
Would that be
I?
a 20?
That music threw me for a loop. And then do I need to change the last one at all, guys?
No.
Okay, guys, I want you to help me. Negative 11, is that right? Okay, here we go. Let me change colors here. So when I do row 1, row 2, guys, we're really concerned about which column, the X's, the Y's, or the Z's now.
Why?
Okay, take a look at the Y's in the first two, plus 18Y, plus 18Y. So you can add row 1 or subtract row 1 and row 2.
Subtract 'em.
How about row 2, row 3? What are we going to do there? All right, help me with the top. What's 18x minus 12x?
6x. Success.
What's 18y minus 18y? Plus what?
Negative 6z.
40.
You subtract a negative. Wouldn't this be like adding 24z?
And that's why there's no
That's-
solution.
Well, not quite.
32, 34.
But Gabe, I'm going to back up on this. It's pretty easy to make a mistake, isn't it?
Yep.
Because I did that all second hour. Oh boy, I was awful on second hour. What's 18 minus the 28, kids?
42, 28.
18 minus 28 would be negative 10, wouldn't it?
Yeah.
Okay. Now, guys, watch what happens in this next one.
Nothing, nothing, and nothing.
What's 12x minus 12x going to be?
Nothing.
What's 18y minus 18y going to be?
And that's why there's.
What's negative 24z minus negative 24z going to be? So if I have nothing, if all this is just going to fall out, isn't it? If everything falls out, it really falls out to be what value then?
Well,
But then you're in there.
they're incorrect.
What's 28 minus negative 11?
No, I'm no math scholar.
But that's the point where I think I did something wrong.
Yeah, this is when I think I made a mistake.
But here's the deal. I've already kind of set you up to say what's happening here.
No, it's the love.
And let me explain this to you guys. What may end up happening sometimes is more than, like in this first one right here, how many variables fell out here? Just the y's did, right? We said, let's get all the y's the same, but guys, take a look right here. If I double this, doesn't this one become a 12? If I double this, doesn't it become 18? If I double the 12, doesn't it become that 24? The thing of it is, the only way you could have a solution is if this value would have been 28 right here. If you get some kind of weird comparison like this, and this is the part is like, whoa, 0 and 39 are now the same number, you are going to be like, what?
That's the moment we lose.
Choked on a little spittle.
Give that again.
Yeah, that can't happen, can it?
No.
If something like that happens, you get a comparison like 0 is equal to 39 or 7 is equal to 14, guess what this implies already?
Incorrect.
Because once x, y, and z all fall out, can I even solve for any of them?
No.
Absolutely not. So this means what, kids? You can't solve that. There's no solution.
Too bad.
And the nice thing about no solution ones is that you don't have to keep on going. Right? Now guess what's going to happen also to you as well? You're going to run into a situation where you get a comparison like this. 5 equals 5.
Was that all real?
Is that statement true or false? And that's going to be the condition when not no solution, but
Oh.
Oh, it is in many.
I'm going to stop there. You guys take a